Hey everyone, welcome to another video of hok'stutoring. Today we'll be going through a tutorial video going through chapter 2F question 8. So this is going to be on your types of simultaneous equations, and specifically we're going to be looking at the three different types. So the simultaneous equations where you get a unique solution, no solution, or infinitely many solutions. So without further ado, let's get into the video. Right, question 8, let's have a read. Part A says solve these simultaneous equations. 2x minus 3y equals to 4. That is equation number 1. And then you've got equation number 2, which is x plus ky equals to 2. So that's equation number 2, where k is a constant, meaning k is just a number. So let's get into A. This one shouldn't be too much of a problem if you know how to solve simultaneous. So I'll write them down. Equation number 1, 2x minus 3y equals to 4. And equation number 2, you have x plus ky equals to 2. And it's set up in a very nice format. Both equations have the same terms in their, in order, x, y, and then equals to a number. So with this, the best way, and as you remember, and this could be a good revision for you, there are two different ways to solve simultaneous equation. Technique number 1 is substitution. And then technique number 2 is elimination. So that's your two ways of solving simultaneous in methods. Because the equations are in this format, it is better to use the second form, because all you need to do is, well, we just need to eliminate one of the variable, right? And we can immediately see that x can be eliminated quite quickly. You just need to multiply equation number 2 by 2. And what you end up with is, well, equation number 1 I kept the same, 2x minus 3y equals to 4, but equation number 2 now becomes 2x plus 2ky equals to 4. And what you can do from that is you can now subtract and eliminate one of the x values. So over here, 2x, and I'm just going to put a minus, that's our step, 2x minus 2x equals to 0, and you eliminate the x essentially, so 0x. And then you have minus 3y minus 2ky. We can't do much about that, but then on the right hand side you have 4 minus 4, and you get 0. So guys, you've now eliminated the x and you only left with the y. We will now group the coefficients together, and when I say group, I mean just essentially take out the y. So you'll get, so about y over here, you get negative 3 minus 2k equals to 0. And the point of part A is to really just solve the simultaneous equation. So in this case, we don't care what this value is. If my y is equals to 0, well, then that solves my equation. Because when y equals 0, whatever value that is, 0 times that value would always equal to 0. So that means my unique solution in this case, or one of the solution, is y equals to 0. And if you know y is equals to 0, you can also then solve for x. So we just need to sub y equals 0 into one of the equation. We'll sub it into equation number 1 because we know we don't have any constants, no k's in there. So let's do that. 2x minus 3 times 0 equals to 4. 2x equals to 4, and therefore x equals to 2. So one of your solution is, well, 2, 0. X equals to 2, y equals to 0. Now you have to be a bit careful over here. This is actually not your final answer. You might get maybe 2 marks out of 3 or 1 out of 2 marks in this one. So the point that you have to look out for is back into this equation right here, okay? So this is important because what we initially said was whatever value this is, as long as y is equals to 0, then you get this, the equation is satisfied. But if you think of it from a different perspective, if you look at this bracket instead right here, because we have a constant k which we don't know the value of, well, if we let k equals to a number, but then that number makes this whole bracket equals to 0, then whatever y is, then you'll always have a solution, right? So that can work either way. So one way you can think of, oh yeah, y equals to 0, therefore my equation is satisfied. Or the second way of thinking about it is, if minus 3 minus 2k is equals to 0, which if we try to solve for k, that is negative 3 on 2. So if k is equals to negative 3 on 2, then this solution is, or this equation in this sense, is also satisfied. So what does that mean? Because if k equals negative 3 on 2, then y can technically be anything, right? Y can be 5, and then 5 times 0, because the bracket is now 0 when k is equals to this number, negative 3 on 2, then that's also then equals to 0. So this is the confusing bit, okay? Which leads in very well into part B of our question. So part 1, they just said solve the simultaneous equation, and we've just solved it right here. When x equals 2, y equals 0, you get a solution. Now part B, and this links back to what I just talked about over here when k is equals to negative 3 on 2. Now you need to be careful, okay? Gonna put it right here. So B, find the value of k for which there is not a unique solution. So let's think about that again. When k equals to negative 3 on 2, what happens to my two equations right here? Well, equation number 1 is 2x minus 3y equals to 4. Equation number 2 is x plus ky right here, but then that k becomes negative 3 on 2y, and the right hand side is equals to 2. So that's equation number 2. But if you try to, just simplify or try to write 2 in a different format, then what you end up with is, well, if you just move the 2 up here, so multiply all terms by 2, so that we get rid of this denominator, you get 2x minus 3y, you multiply right hand side by 2 as well, you get 4. But you can already see that these two equations right here are exactly the same. 2x minus 3y equals to 4 is equation number 1, and 2x minus 3y equals 4 is also equation number 2. We simplified it, and when you let k equals to negative 3 on 2. So what does that mean? Well, as we learned in the topic video previously, when your two equations are exactly the same, then that means they are the same line, and the same line, well, what happens with the same line? They are, whoops, I'm going to draw that properly. If they are the same line, then they will always intersect each other at all points. So you actually have infinitely many solutions. And that happens when k is equals to negative 3 on 2, just as we found over here. Because when k equals negative 3 over 2, then these two lines have the same equation. And that answers part B, because part B asks find the value of k for which there is not a unique solution. Well, when k equals negative 3 on 2, there is infinitely many solutions. So there we go. That is your answer for part B, okay? Guys, that is question 8. Fast and quick and easy one, nothing too difficult. The only part that I would like to point out is over here for part A, where you have to be careful. Your unique solution when you're solving for it is indeed x equals 2, y equals 0. But you also have to keep in mind that k cannot be negative 3 on 2, okay? Because if k is negative 3 on 2, then you have an infinitely many solution, which would not allow you to find an x or a y value at all, because there's infinitely many solutions, okay? So guys, that is it for this video. I hope you found it useful, and if you did, please leave a like and subscribe, because I would really appreciate it. Thanks for watching, and I'll see you in the next video.